Welcome to Spectra 2025, the largest virtual AI summit powered by 3AI. Thank you for joining us today. The topic for today is building robust and scalable AI and Gen AI architecture for enterprises, best practices and implementation approaches. Let me begin by thanking 3AI for this opportunity, and special thanks to Nandakumar Ramaya, the CTO and co-founder of 3AI, fondly known as NK, for curating this incredible panel. Let's quickly decode this topic. So, in an enterprise setting, what does building robust and scalable AI and Gen AI architecture mean? A couple of things. One, is it able to handle real world unpredictability, such as edge cases, messy data, etc.? Second, is it able to scale seamlessly across business units, geographies? And what about increasing data and model demands? Is it flexible enough to adapt to evolving technology and can handle real world challenges autonomously? Maintain enterprise grade standards for security, governance, and performance with sustainability built in. So, Anusha, based on your experience, when an enterprise begins its AI journey, what are some of those critical elements that you need to uncover during the discovery phase?
Thank you so much, Veena, for the beautiful question. With the progressive landscape of artificial intelligence, Gen AI has emerged as a paradigm shift for the enterprises. However, structuring end-to-end Gen AI applications that are scalable, observable, and robust poses a challenge. Now, from efficient and smaller models to agentic systems capable of independent decision making, the opportunities are witnessing an expansion. This pioneering technology is poised to modify the industries by transforming the value chains, the operating models, and the economic dynamics. Discovering the breakthroughs, exploring the ways to innovate is expected to turn the possibilities into real world impact. Now, reinventing this technology, it continues to be an effort emphasizing on responsible, safe, and secure usage in terms of both people and technologies. So the key focus areas should be on autoscaling, debugging, model monitoring, trackability, and observability. So starting with, it should be like identifying the objectives, such as the explicit data that needs to be extracted, types of documents that needs to be handled, and the anticipated output format. Second should be defining the application requirements in developing a RAG system for the document processing. The third can be outlining the real use cases, such as augmenting the customer support via better information retrieval, extraction of data for business intelligence, and automated data generation or report generation. And it can be followed by describing the functional requirements consisting of the ability to analyze the preciseness and the speed of the retrieval process with the amalgamation of the capabilities of the existing systems. So ensuring that there is a robust development setup with the required software dependencies and a capability and compatible operating system. Capable and compatible operating system. So with the growing usage, the architecture needs to be able to address and cater to the loads without the manual intervention. Like, for instance, a container-based architecture. It enables the AI applications to either shrink or to grow as per the demand or necessity. So given that the architecture components are scalable. So this further proves that to be beneficial for the teams catering to the inconsistent patterns. So this data discovery, it poses to be an iterative process requiring the amalgamation across and amongst the teams. So in order to deliver the maximum, it is essential that the AI systems are in sync with the business necessities. So the need for the models catering to domain-specific nuances and terminology is gaining traction. If we take like by methodically defining such aspects, a roadmap can be formulated, thereby ensuring that the entire process it delivers tangible value and caters to the user's expectations. So a successful Gen AI architecture framework, it needs to basically focus on the adaptability to scale without the widespread infrastructure demands, thereby catering to the changing usage patterns and changing scenario.
Sure, sure. Thanks, Anusha, for highlighting the importance of discovery phase. Building on that, Vijay, given the explosion of unstructured data and the need to unify data across silos, how do you go about building a strong and flexible data management system that truly supports AI and GenAI at scale?
Sure. Sure, Veena. Thanks for this question. And I totally agree with what Anusha has mentioned about the various use cases that can be solved in Gen AI and the importance of data, right? And I would like to highlight a couple of my observations and thoughts around how one has to think about setting up the right data management system to power these Gen AI applications, right? Um, Basically, I would categorize this into two parts, right? One is the data and the metadata of the data, right? So how do we deal with all of this while ensuring that everything is governed properly, right? So at a very high level, there are four aspects that I would focus on, right? One is making sure that all the data across different departments within an organization or enterprise are getting to a single place. Basically, having unified storage is very, very essential, right? Because it's no more a report that we are generating or analytics use case that we are trying to solve, right? It's more about getting all the data together, trying to build a context, and then trying to solve the problem from a Gen AI standpoint so that it is more relevant from a personalization standpoint and also from an organizational benefit standpoint, right? So getting the data into a single storage system to make sure that all the data can be correlated to do the right analysis is very important. And the other aspect is making sure that the proximity of the data to the agents is right, right? So, for example, data can be coming from batch systems or it could be coming from real-time data processing pipelines, ensuring that the data is actually stored the right way and near to the pipelines or near to the processing logic, right? It could be agent or a pipeline. That is very, very critical, especially when we are dealing with large data sets. Any delay in the processing is going to impact the user experience, right? So that's where we need to make sure that the proximity is really, really important. And to deal with all of this, coming up with the right lakehouse architecture and ensuring that the right frameworks for ingestion, both batch and streaming, are put in place. And with the growing use cases around Gen AI and artificial intelligence, ensuring that the schema evaluation is taken care of during the data setup itself, right? And the pipeline setup itself. And also ensuring that the data versioning is also maintained, right? Because there could be cases where for a given Gen AI use case or for any use case, right? You might want to go back and refer to a data set that is there at a given point of time. And without having support for data versioning within the data platform, it's going to be very difficult, right? So ensuring that this feature is in place within the data platform is very important. So while unifying the storage is one part and proximity of the pipelines and the data is other part, understanding the data as it comes in is another crucial aspect of the whole ecosystem, right? Can we annotate the data, be it structured or unstructured or semi-structured, as the data is coming in and when the data is stored into the storage system, so that given use case or analysis that needs to be done to cater to a given Gen AI a use case can be done based on those annotations. Because it's more about how do we build the context when we are sending a request to the LLMs or any model, right? Which basically ensures that the response is more appropriate. So the context building is really dependent on not just the data, but also the metadata. And here, metadata is referred to as annotations in the point that I'm trying to make, right? So that's very, very important. And ensuring that the technology behind the scenes is put in place so that these annotations can be done seamlessly across all the formats, right? I think that's very, very important to make sure that we cater to the Gen AI use cases the right way. Um, Having said that, I think one last piece that I would like to highlight is, while we get the data from different systems and try to put that in a single place, do the data sets still stay disconnected, or are we able to correlate these data sets so that we actually create a knowledge base, right? A connected knowledge base, so that it's more useful for Gen AI use cases to build the right context, right? Both from data standpoint and also from metadata standpoint, right? I think that's another thing that needs to be taken care of while setting up the right data platform, right? Now, if you look at this, basically there are different types of storage systems and different types of pipelines and agents coming together to solve the Gen AI use cases, right? But how do you ensure that there are right governance and controls in place is the other aspect that needs to be taken care of, right? I think having a holistic view of all of these aspects, having the right frameworks, having the right storage systems, and the controls on top of it is going to ensure that you have the right data management platform to support better use case serving for Gen AI. So
Sure,
that's a
sure.
high level view that I would like to share.
Okay. Thank you, Vijay. I think you brought out some of the interesting points around the schema and annotations. Thank you so much for that. And we'll move on to Kiranjit. Kiranjit, yeah, we spoke about data management system. What in your view, is important in terms of data science itself?
Yeah, sure. Thanks, Veena, for the question. I think from a data science perspective, when it comes to probably building a robust and a resilient AI architecture, we need to be more considerate about it, right? Because gone are the days when it was just about building models and then sharing the results, the predictions, and recommendations on flat files. With the evolving data we call big data, right? Enterprises need to think of a more robust architecture to deal with the big data in the real time, and to do that we have to first and foremost find the right model for the use case that we are trying to build. So for example, just like from a Gen AI perspective, when exactly we should be using a small language model or a large language model, right? Just taking an example to discuss about this particular point. For example, sticking to a chatbot use case, right? If a particular enterprise wants to build a chatbot system specific to a particular product, definitely it's on a very small scale, and they want to kind of uh, host it on the IoT devices, right? So that's the place where SLMs can be used instead of the large language models. But if they want to generalize it a bit more and kind of also embed emotional intelligence into it, uh, give it a more content generation angle, then I think that's where LLMs will come into picture. So it's very much crucial to find a balance between which particular base model should be selected for what kind of use case, because SLMs are more focused about efficiency and precision, but then LLMs are more focused on the broader understanding, general purpose, and a bit of a complex task, right? Uh, that brings to another point, which is from a deployment strategy, like what kind of strategy we should be always following from a data science perspective. Is it on-premises infrastructures or cloud computing? Because each has its own pros and cons. Um, Wherein on-premises definitely offers greater control and security, while the cloud provides more scalability, more flexibility, and potentially low upfront costs because it's on the requirement on the go basis, right? Yeah, I think let me share an instance. For example, let's say I've heard that in the news wherein a company didn't plan it out properly and exactly what and how they would be going ahead with these architectures, but they simply built a chatbot system using open source GPT models and shared that particular product across the team members to test it out. And given the token cost that we all know, right, that the cost came to a very huge amount. So if proper planning would have been done and on-premise setup would have been done, like using offline SLM models just for a simple chatbot system, or a particular GPU machine if they have in their enterprise, probably could have leveraged that. That would have reduced the cost to a lot of extent, right? So yeah, I think these are the couple of areas from a data science perspective I feel.
Sure. Thank you, Kiran. Thank you. You brought out the point that cost management is also very important, and you need to keep an eye on that as you make the right choices there.
Right, right.
Over to you, Jay. What is your perspective on this, and how do you ensure that you have robust system integration also in place?
That's a great question, Veena. Thank you for asking that. To start with, I completely agree with what Kiran had to say, right? And I like to add a few reflections from my own experience of integrating AI and Gen AI models into the production or enterprise environment, right? So one key learning is that integration is never a last mile task. Usually, people start from development and then think about deployment, but in actual world, from my experience, integration always has to be the starting point, right? So before you build anything, you need to have clarity on where the model will run, where it will be deployed. Is it going to be an existing system or a completely new greenfield architecture, right? Questions like what are the protocols being used, what are the data formats, and what are the APIs that we need to align with, right? These are very important to start with, right, before even we build the models. I'll give you a very small example from one of the fraud detection model that we were building. We realized halfway that the API is capped at 100 milliseconds right now, which forced us to stop that work and refactor the whole work using a lighter version. Now this could have been avoided if we thought about system integration and deployment in the beginning itself, right? And especially now with generative AI and agentic systems, integration becomes much more layered and complex, right? Unlike the static model that we used in the ML and the deep learning eras, you know, uh, the agentic models, the Gen AI models need more contextual memory and need more state tracking, right? So this is where examples like customer service bot that do a lot of reasoning over multiple documents need we need to persist not to the last query but the entire interaction chain, right? So from my experience, tools like langchain and semantic kernel have been super helpful. Adding to it, from the engineering standpoint, it is very critical to log all of these intermediate steps, not only the final output which we all do, but also the intermediate step for observability and debugging purposes. For example, in case you get a wrong summary, because of logging and monitoring, you exactly know which is the part that didn't work as you desire, and you can narrow down to only solving that purpose. To summarize, robust and scalable architecture must uphold the three key principles of CIA, which stands for confidentiality, integrity, and availability, which also means there is a responsibility of role-based access to prompts and memory, encryption of audit logs, and fallbacks in case the model or endpoint fails. All of this, system integration, contextual state handling, and orchestration has to come together like a well-conducted symphony to ensure that success in the production scale Gen AI initiatives is guaranteed. Yeah, I just like to stop here.
Got it. Thank you, Jay. So, integration is the backbone of Gen AI or AI architecture construction, is what you're bringing out. Thank you for that. Kiran, back to you. Could you cover some best practices on the deployment side and also some of the agentic trends?
Sure, Veena. Yeah, definitely. And could relate more to the example that you spoke of, Jay, also about that robust architecture setup. Completely aligned over there. But just to add on to those couple of things from a best practices perspective, MLOps is something which we should be adhering to and adopting to productionize the machine learning models, right? And which helps in measuring the performance of the models, the model management through versionings, unit testing, continuous monitoring, the quality checks, and so on, right? We need to place proper guardrails also on the models, wherein we need when exactly we need to retrain it and how to control the different versions in the production environment, right? Because we don't want anything to happen during production. So there are a couple of platforms, right? Like ML flow, the weights and the biases, or the cube flow, to track the model versioning side of things, to take care of the hyperparameter tunings, and even just from a starting point perspective, like if we talk about the data, we have DVC tool, which kind of controls the data versioning side of things, right? And we have platforms like Bitbuckets and GitHubs to push our codes and create a versioning of our codes from all the angles, like from a staging point of view, from a production point of view, as well as from a development point of view, right? But a couple of more best practices that I think we should definitely be adhering to are the feature stores. We should not forget about that, because it helps in kind of reusing the features across the different models that we are building, and that helps in kind of reusing the same exact features that, and avoid this duplication side of things, right? And definitely the human intervention, right? When exactly we need to put human in the loop for any of the Gen AI models, or even in machine learning side of things, the data science side of things, uh, use the reinforcement learning, human feedback, and like Vijay, you had mentioned earlier, right? From the connected knowledge graph perspective. I think coming to the trend side of things, Veena, like you mentioned, I think going ahead from an agentic AI perspective, emotional intelligence is one of the focus areas that I believe which will be embedded, wherein the AI agents will develop the ability to understand and respond to the human emotions instead of just trying to find some relations with the queries and the answers and stuff, and fostering more natural and engaging interactions, right? Probably also taking into consideration the sarcasms, like differentiating between sarcasms, questions, comments, and statements and such, right? Probably there's with the incoming of the SLM, we can try to integrate that with the IoT devices and personal devices, and which couple of enterprises have already done that, and there's still a scope from a domain perspective, and increase the domain specific intelligence too, right? Which definitely leads to the better business outcomes. And one more is incorporation of the ethical AI, which will prioritize the ethical AI development and deployment side of things, which ensures that, I think, the transparency and in the agent decision making process, and also address the potential bias. I think these trends definitely are going to be the next for the agentic AI side of things.
Sure. Thank you, Kiran. Kiran, you were talking about versioning and how ML ops is very important. Tracking the drift is very important, and how do you ensure that you have the right system in place for scalability. Over to you, Jay. What tools or systems do enterprises use for monitoring performance real time? We have covered discovery data, we have covered data sciences, we have covered ML ops. So, how do you now, look at monitoring various aspects real time?
So here I like to bring the a perspective of security, coming from a cyber security and working with banks through most of my career. I've always seen security not as an additional add-on, but more like uh, a security in design, right? So there was a time where AI systems were more of an experimental black boxes, and people used to be very excited just looking at those black boxes. But I think now AI are not considered as separate. They are, they are treated as a part of the production grade software, with a small difference that although software engineering is pretty much deterministic, but AI outputs are still date probabilistic, right? So that makes the security, observability, and traceability absolutely essential, even more essential than the traditional black boxes, right? And for that purpose, traditional security tools are not enough. This is where you have to have more customized framework like AI for SOC to address ML specific, AI specific, and specifically generative AI risks, such as prompt injection, model hallucinations, jailbreak attacks on the system prompt, data leakage on what the data was trained on, and especially in AI agents, excessive agency. So these are things where the agents give you give too much autonomy to the agents, right? So there has to be very well balanced about it, right? At the heart of monitoring, I believe SIM, which stands for Security Information and Event Management Tool, is very important. So this is a tool where it can ingest log for every AI system and can raise alerts and anomalies based on what the data is being ingested, how much is the token usage, what are the inference timings, inference quality, the API is being called out, right? So things like whether just imagine in case your tokens limit or your token usage just triples overnight, right? So what could that be? Is it a resource misusing it? Is it a model being hit by external attackers for a probable distributed denial of service, or maybe some other compromise, right? Have your key been compromised? So all these things can be used. And the interesting thing is even generative AI can help here to autonomously identify new threats. Instead of a manual security monitoring team doing all of that, generative AI agents can sift through all of these logs, can identify those patterns, and save the day for us. Along with that, there is an interesting system of guardrails, right? So guardrails such as policy enforced, output validation, and observative layers that can track the model input and the quality of output can secure and make your enterprise systems resilient and trustworthy, right? So some
Sure.
examples of SIM are Spunk, Microsoft Sentinel, and so on. Yeah.
Sure. Thank you. Thank
Yes.
you, Jay,
Yeah,
for the
thank you.
discussion. In the interest of time, I'll pause here and then move on to Anusha. I had a question for you. Across data, MLOps, data sciences, everything that we do, including security, how do you ensure that you've embedded sustainability there?
Okay. Going ahead, growing advancements in the pioneering technologies, they are expected to lead to a significant rise in terms of the computational demands, alarming the risks about the ecological impacts of large-scale model training. So from a significant sustainability perspective, if you ask, like, the implementation of the strategies that minimize the energy consumption is gaining widespread traction. So if we take the examples, like, for instance, in order to integrate sustainability into the frameworks and architectures, catering to the demand as well as the supply side, both are important. Supply side, it includes categorizing the use of clean energy sources, and the demand side emphasizes on optimizing the AI systems to be more efficient. And this can be elaborated by focusing on prioritizing the fact that the training models, they are run by the net zero and the efficient data centers. Number two, incorporating responsible AI practices and strategies to minimize the risk and the environmental impacts can also play a significant role. Number three, developing the energy efficient AI models. For instance, like prioritizing the energy efficiency at the time of designing. The frameworks also play a major role. Techniques such as knowledge distillation, quantization, data pruning, they help minimize the computational complexity of the models. And the last point, which I would like to pay emphasis on, is like transfer learning augments the utilizes of the pre-trained models, thereby minimizing the requirement for the resource intensive retaining. Amalgamation of the learning process, which processes the data across disseminated devices instead of centralized data sources or centers. It also helps in minimizing the overall energy load while augmenting the privacy as well.
Sure. Thank you, Anusha. Thank you for detailing various green measures for AI architecture, for a robust AI architecture. A big thank you for the enriching discussion. Thank you, panelists, for joining us today. I would like to maybe take a few seconds to summarize some of the key takeaways from this session. One, Anusha, we spoke about how do you keep the end goal in mind and uncover all the elements during the discovery phase itself, and that is very important. And Jay, you also brought up the point that system integration is a backbone. So in fact, that has to start from discovery. Vijay, we spoke about data management and how intelligent systems basically require an intelligent ecosystem, and feedback loop itself is very important. And context capturing using knowledge graphs that bridge the gap. And Kiran, your discussions around how the products are solutions are typically interacting with human beings, and hence you need to combine the emotional intelligence context as well, apart from multimodal understanding and ethical reasoning. Jay, we spoke about system integration, logging, and monitoring, and how root causing becomes easier and it becomes precise when you do it autonomously using the agents. And some of the other security measures, also mitigating the security risks. And from sustainability standpoint, Anisha, what you were also bringing out is that you need to look at both supply and demand side of things, and ensure that you're assessing the entire gamut of things for optimization and monitoring. Thank you, everyone. I truly enjoyed the discussion, and I really look forward to continuing the conversation beyond this session. Thank you.